So, to start, my name is Conrad Bielski. I was invited here by SIOS on behalf of the Copernicus Support Office. And that's exactly what I'm going to be talking to you about today. The Copernicus program, essentially, and all the different types of data, services, satellite imagery that you can get access to, plus more. And hopefully this will spark not just your curiosity, because I'll go through a lot of different data sets that may not seem directly relevant to you at the beginning, but once you get to sort of understand a bit better what your problems are, what Earth observation can do for you, then hopefully you'll start making those links and taking advantage of this wealth of information. The other thing I wanted to just mention before I start, I did upload a list of links to the shared area where you can find all the links that I'll be discussing. I don't see you, so basically you can be taking advantage of that and looking around, and definitely feel free to ask questions during the presentation, and of course after and during the hands-on sessions if we need to look at certain things closer. Okay. Great. There you go. So again, Conrad Bielski. I might be a little different than some of the other presenters in that I'm currently have my own company called Eoxplore. It's a Earth observation consulting company, and I've been doing essentially Earth observation work. A lot of it is automatic information extraction, so algorithm development for a variety of themes, including vegetation. So from a land cover, land use perspective, agriculture, but I've also looked at other things. So natural hazards, disaster modeling, and essentially what I try to do is try to link Earth observation information based on the needs of the clients. And just to give you a bit of background, the reason I also know Copernicus quite a bit, while I was still doing my research sort of work, I was at the Joint Research Center of the European Commission, and they're developing some algorithms again, both from a image processing perspective. So we were doing automatic mosaicing back then for European data set, a single image. That was just before Google Earth came out. And then later on, more focusing on natural hazards and disaster modeling services. So basically trying to help those in need after a disaster, and using EO plus other information to do that quickly and efficiently. So just a quick overview of what I'm going to go through. Just a quick show of what is the Copernicus Support Office. That's why I'm here. Then I will dive deep into the Copernicus program and its services. So I'll explain more about that. Then I will also give a short overview, I would say, of the Copernicus Sentinels, because we will go back to them during the hands-on exercises to talk about them much more and present them in the hands-on exercises. If we have time, I'll give a few examples, demonstrations. If not, we can also move that into the hands-on. So Copernicus Support Office, it's one of these parts of the Copernicus program, essentially to try and support, coordinate, and push the Copernicus program, its services, and the data to across Europe. So it's used as much as possible. Remember, it is your tax dollars or tax euros, sorry, at work here. And of course, we want to build the community around it. We want to see it succeed, and we want to see it being used in all kinds of solutions. Here are some of the current companies behind that. So again, they're about communications, they're about different markets, and they're about entrepreneurship. So how can we use EO with any other technologies to push Copernicus forward? Again, some of the directors and the team. I mean, if there is anything about this course, not this course, but this lecture that you wanted to say to somebody or suggest ideas, please feel free to contact them directly. So as I said, the CSO, the goal is about developing and strengthening networks, providing technical and efficient support, communications. I mean, that's important. You'll see once we start talking about all the information and services that are available. Also looking at strategies in order to keep Copernicus competitive and a leader globally. And then, of course, as we're having here, you know, how do we bring Copernicus to events? And here we're doing it through this SIOS class. Okay. Copernicus program and services. Here you'll start to be able to use the links that I sent. Essentially, this is a multi-million euro program. It has quite a long history, but I think it really began once the name Copernicus started. And of course, one of the main assets are the Earth observation sentinels. However, that is not the only part, because the space component is what is feeding very much the Copernicus services. And it is all those links together that is bringing the data and the information that's coming from them to you and anybody else who wants around the world. The important thing is here that we're always striving to be free and open. And we're always listening to push the Copernicus program further, okay? Yeah, let's keep it at that since we don't want to get too political. And again, here's just a quick overview. So as you see at the top, observation, that's mainly from the Earth observation satellites. And then we have the different themes from the Copernicus services, and we'll go through each one of them. And I'll try to tease out where, well, where you could potentially see links to what you're doing. Because again, while the theme of SIOS is vegetation monitoring, well, vegetation is linked to a lot of different things. And of course, some services will look more closely at certain aspects than others. And as you can see, this kind of data and services are for policymakers. So again, if you are looking to influence ideas about climate change and you want to push that further to actually make the correct sustainable changes, fantastic. You know, that's the way we want to use this. The public, of course, to get them to understand and better view the world around them. And finally, I'm sort of bigger part of the private and commercial, where we can build new services based on the Copernicus ecosystem in order to keep Europe at the forefront of technologies and services. So users are at the base, and you're the one that's going to be driving some of this innovation. Again, this is more of a slide just to give an overview of sort of the ethos of Copernicus in general. But we definitely, the idea is for you to take advantage of as much as possible, because we know that you have the ideas, you have the drive, and we just want to help you along. We as in, well, we're all here in it together, and we just want to make this world a better place. So again, some pretty important things to remember. The Earth observation imagery is full. So everything is free and open data policy. So essentially, you can download it and you can use it in whatever way you want. That's up to you. Everybody has access. So even though it's a European program, it is globally available to anyone. And the number of users keeps growing. So I would say the 300 registered users is probably an old number, and it doesn't include all the users from other services, which we'll see later on as well. Okay. So if we start by looking at some of the services here, in no particular order, but again, I just sort of thought about how Svalbard is in the middle of the ocean. So I'll start with the marine service. This is basically, it focuses on ocean-related information and products, which again is maybe a different field than what most of you are looking for. But I did hear people sort of talking about glacial movement, ice movement, degradation. These are the kinds of things that you can potentially find here, okay? And again, because it's a service, it is again free and open to that, and it's probably worth taking a look at what types of data might be linked to the work you want to do. So that's why, as I said, maybe, you know, even though you are interested in things like glaciers, they do move into the water gets affected, et cetera, et cetera. So this is a place where you can take a look and see the different types of information that is being produced. So another interesting Copernicus service is the atmosphere monitoring service. A lot of the focus is about air quality and atmospheric composition. Of course, this is what's normally found in the news. But if you start looking at it from a vegetation perspective, this kind of information can still be applicable to some of the work that you're doing. For example, even solar radiation. If you want to know how much incoming sunlight is coming over a season, you can find information here. Again, climate forcing. So potentially what could be happening in the future based on based on vegetation or other models that are being used based on the atmospheric information that we're getting from the satellites. Of course, air quality could be something of interest. Again, it's linking what we have available to to the themes that you're looking into. Sorry, let me just see, because because I'm in full screen mode, I don't know whether people are asking questions. Can you let me know?
Yes, on the chat box, I didn't get any question yet, but
okay.
I would let you know in between if I get some questions on the chat box.
Yeah, because hold on, let me see if I can turn that on then. Oh well. Okay, sorry. So next up. And just to show you sort of some of the information we can get, of course, back in June, everyone was discussing about how nice and clean the air was. Of course, this is where they were getting that information from the Copernicus Atmosphere Monitoring Service, which is providing regular information about the atmospheric compositions. And they also have air quality forecasting. So it's not just about seeing what happened, but if you're interested in forecasting, and again, I'm pointing to interesting things like grass pollen and birch pollen, which are vegetation linked. However, these are being produced within the CAMs. And again, a lot of this information is available to you in a variety of databases. So you can take advantage of it or not. But again, it just depends on what it is that you're looking for and maybe the links that you're looking for within your studies. Here's another one that could sound very far outside of the domain we're supposed to be sort of focusing on. But the Emergency Management Service also has information about vegetation, essentially. So specifically, if you're interested in places that have been affected by certain types of disasters, for example, wildfires especially, there have been quite a few maps created for that, both in Europe and around the world. So that's one thing that you can take a look at. Another one is, of course, flooding. So, you know, how does flooding is becoming a very big part of climate change and the extreme weather issues that we're starting to see. And flooding will, become more severe, and it can affect a variety of issues. Of course, we're trying to see whether vegetation can help. I mean, that's from a sustainability perspective. Again, then it's about understanding where have we seen the biggest issues and how can we apply our knowledge to fix those issues. This is just to show you that we have two different services. So the European service is very local in nature. So the resolution and forecast time is very good. However, we do have an open global awareness system that provides, let's say, coarser information, but still allows you to monitor areas and regions for flood. This is the Wildfire Monitoring Service. And here again, if we consider the fact that wildfires are essentially vegetation that is being burned, what is really interesting about this is you can monitor the state of the vegetation from a fuel perspective, but that also means that it means that the fuel is being drier, and in general the vegetation is changing because of the environmental conditions. So again, this is something that can be viewed globally. Also within Europe, especially, and it's a weather-based sort of prediction, but it provides you with vegetation information that you may not consider, for example, or think that is available easily. And again, vegetation related is the opposite. So drought again. This is the Drought Observatory, another both European perspective as well as a global perspective. And this is updated. These are all operational services, and therefore they are updated consistently. Yeah, and as I said, so we can see this both locally and globally. Now, another very interesting one is the Copernicus Climate Change Service. So here it is very much climate focused. And so they have a large number of data sets that go both into the past and the model data into the future. That one can use for relating the changes potentially that you're seeing in the vegetation. What is very interesting about this one They do have, I guess you can call it a SDK. So this is a programming library that you can use in order to simplify the access to the different data sets. Because of course they're global data sets in nature, and a lot of data available, which you may not need or you want to process. So again, just some examples that that we can show here, that potentially can be available to your work. Sorry, I have a quick question here. Can I use emergency management service in regard to dust storms and also mountain related hazards? Okay, so my first suggestion, Timur, is to take a look at the list. I certainly know that debris flows are covered. That's a very particular service because it requires, normally it's activated when something significant occurs, okay? And therefore it is only activated for certain areas. So you might get lucky, especially for if you're looking for a particular disaster. But I'm sure that if you're just looking for some examples of avalanches or debris flows, then I think you can find them there. Yes. I hope that answers your question. Okay, great. Okay. Yeah, so just wanted to say, and as you can see, this data set is quite old, certainly much older than the Copernicus Sentinel data sets that we have available. And so, you know, these are used to go both back in time to see what happened and compute the potential changes due to climate. Now we're getting closer to, let's say, data sets that are more in line with vegetation state. So the Copernicus Land Monitoring Service. As you can see from the slide, they have different products, so which span basically from the global scale all the way to the local scale. Here, local generally means Europe. However, of course, you can see how these local products were produced, and technically, you could be able to reproduce them for whatever area you want, because much of it is based on Sentinel imagery. Okay, again, and some of the imagery and reference data, that is again mostly European, but it provides essentially ground measurements for validation uses. So you can it's called the Lucas data set, but we're talking tens of thousands, probably now over hundreds of thousands of pictures that have been taken across Europe since, I believe, the 80s on a regular basis. Okay, so it's a huge number of, or it's a large number of data. Again, depending on the type of work you're doing, you may need, you know, artificial intelligence today is big, and this is something that could be used for those types of research, for that type of research. So just to take a look at some high resolution layers, imperviousness, I at first thought you might think, well, what does that have to do with vegetation? But essentially, if you reverse it, anywhere where there is vegetation means that your imperviousness goes up, right? Yes. So essentially what we're looking at, I mean, the data set is called imperviousness, but it's about where water can go through, especially in the urban context. And so all areas where water is getting through, normally that is considered natural. So these are data sets, I mean, forests again. These high resolution layers are for Europe, but they're already defining very specific regions and specific types of vegetation that that can be used to well, for your work, and already identify regions of interest. So again, even water and wetness, wetness from the point of view of um, areas that are, you know, naturally flooded and therefore have a certain type of vegetation growing there, that can be used to link up with what we're seeing on the Earth observation if we're looking into specific ecosystems. So again, more having to do with vegetation as well as snow and ice monitoring. Within the Copernicus Land Monitoring Service, we have phenology and productivity data sets as well as snow and ice monitoring. You know, when you have the time, I highly suggest to go around, read around, download them, take a look at what you're getting, and see how you can take advantage of it. When we get to the local scale, the Urban Atlas is again, these are European data sets, but the urban data set is for any urban population that has 100,000 and up. And what we're trying to do here is take the Earth observation information and increase the number of classes that are being mapped from that. So it's definitely more difficult to do it as a pan-European product, but we know that in the urban context, the suburban context, we can identify certain types of features that are of interest for the development of urban areas and hopefully for the sustainability of, in general, of the urban and natural fringes. Riparian zones, again, these are vital for biodiversity. It's also about understanding where they are and what is linked to it. So these are very local data sets again. I'm not sure if you know Natura 2000. This is again what does it say here? Sorry. So these are habitat areas that are considered to be important. And again, it's we use the Earth observation to not only map the vegetation, but it has been mapped over a number of years now. And so we already have quite a large data set and a historical data set in order to see how that changes. Same thing about coastal zones. I believe that's a fairly new one, but we're looking at the 10-kilometer buffer around the European coastal area, because that is a fragile area. There's a lot of well, there's a lot of change going on there, and there's a lot of protection that needs to be happening. So these data sets are used to help out with that. Just sort of zooming in a bit more on what you can find in the Urban Atlas. So this is about, I mean, even street layer data sets. So, you know, instead of going ahead and doing it all on your own, you can start with a nice base data set and use that for masking some of the information that you're looking for. Now, if we go to back up in the other direction for data that is globally available, again, we have a different set. Vegetation is one of them. Water is one of them. Again, the list is quite significant, and therefore it's worth going through it depending on what your needs are. again, you know, energy valuable for the understanding of vegetation and you know, how much energy are they getting, and sort of linked products to that. And here again, more types of vegetation information that you could get from the, obviously these are all Earth observation based, but the products are already produced. So you don't necessarily have to go through all the pre-processing to get to this. You can start from here and better understand what are your needs, and then develop your procedures from there. So here's just an overview of essentially what you could see when you go to the viewer. I think I'm looking at NDVI here, which is the Normalized Difference Vegetation Index. We'll take a quick look at that later. But essentially, you're looking at how photosynthetically active the vegetation is. This product is, I believe, a 1 kilometer product, but you are seeing it pretty much daily. Is that correct? 0405, yes. So essentially, you are getting a almost daily look at the global vegetation and how it changes. Of course, you don't have to use the whole globe. You can zoom in on your areas of interest, but this is available, and of course, it's free for you to use for whatever purposes you need. And again, just looking at some of the actual global land service products, we have vegetation state collections, which are again very valuable for vegetation monitoring and research. Here we go. So just some more. This is the soil water index, which basically provides a indication of the water content of the soil. Okay. Any questions before I continue on the services? No? Okay. So sorry, I'm just taking a breather now. So now what we're going to look at is the Earth observation backbone of the Copernicus program. So those are the Sentinels. Currently, there are 4 types of Sentinels flying around the Earth. Some of them are in pairs. So as we can see, the Sentinel-1 has both an A and a B. The Sentinel-2 also has a pair, and Sentinel-3 has a pair. So these are, let's say, the platforms that are used to acquire global data. So it's not just for Europe, it is a global data set. And they're constantly going around. And the hope is that, as you can see, essentially they've been launched from approximately 2014, 2015. But the hope is that these will continue for many, many years into the future. Okay, so the idea is not that, okay, we launched this and, you know, whenever, you know, in a 5-6 year sort of time frame, when they're not working anymore, we forget about it. The idea is that the Sentinels will continue monitoring as much as possible in the same manner as they have been, in order to keep a very long baseline for the future. So just a quick overview. Again, the Sentinel-1 is a synthetic aperture radar. So this is, yeah, it's a radar. It uses radar waves. Sentinel-2 is optical. So again, that's something more closely to what we see in general, or this is definitely the easier one. The Copernicus Sentinel-3 is also generally an optical one, although it does have a radar component. And the Copernicus Sentinel-5 is the one that is currently looking at the atmosphere. So here I'll start with the Sentinel-3. I guess you can say the main reason it was sent up was for ocean monitoring, ocean color monitoring specifically. So that's why you have if you take a look at it, the specifications have 21 spectral bands. These are all from the visible to shortwave infrared. They've been chosen specifically because of certain aspects that ocean researchers would like to monitor. That said, of course, it is extensively used also over land. I mean, the reason, of course, that we say the main objective is sea surface, because the sea surface is certainly much larger. So from a Earth observation perspective, a lot more data has to be acquired to monitor the global oceans and the global water than the Earth portion of it. And as you can see, it is being used for vegetation index, the plant canopy, chlorophyll, water related to vegetation, and the red near reflectance, which is again showing the vegetation stress, or how vegetation is growing. I'm not sure how much you have covered with respect to the remote sensing part, but just to give you a bit of an understanding, let's say, of if you take a look at the spectral bands that are being shown and how they relate to different types of objects, then I'll just do a quick explanation here. But hold on. Okay, so sorry. Vegetation cover product covers Svalbard. Yes, I believe so. That's 1 kilometer, but S3 actually goes from 300 meters to 1 kilometer. So some of the spectral bands are 300 meters, and I believe those are the visible and near infrared. And then there's other ones that are at 500, and still others at 1 kilometer. So if you really like the vegetation cover product, you can actually do better with Sentinel-3. Okay. But yes, we'll cover a bit more of that during the hands-on. I would say Sentinel-3 is being used. To be honest with you, I don't have my hands in all the themes anymore, but definitely. Snow cover mapping is one of those things where certainly affected by cloud cover. And one of the nice things about the Sentinel-3 is the revisit cycle, which is daily. So your chances of imaging spots around the globe consistently are higher because of that. I might be able to answer that question a little later on. Yes, but anyway, just to say, yes, it's I'm sure it's being used. But you'll see also that there's other things that that can be used for snow cover monitoring. Sorry. So what I just wanted to show you here, hopefully you see my my mouse right now, but we've got 26 bands. So what does that mean? it means that we're looking, if you're just thinking about the electromagnetic spectrum, we can see a line of where the reflectance is based on the solar reflectance, okay? So snow is very bright, but then when we get into the longer wavelengths, we see that it's more absorbing. And of course, those who are doing snow will know why that is occurring. But you can see why, you know, people looking at snow are very much more interested in certain bands than, for example, the people who are interested in the vegetation. Because if we're looking at this pinyon pine here, we have this green peak, of course, because in the visible we see that. We have this dip in the red, and then, of course, the near infrared is a valuable piece of information because it's very reflective in that point. So, you know, vegetation people generally are focusing on this area. But of course, you know, mineral people are looking for maybe dips here and dips here. Water, of course, is looking pretty boring, but it's not always about just the water. It's about what's in the water. It's about what's on the water. I mean, if you do take a look at the listing of why specific bands were chosen for Sentinel-3, then you start understanding what are the different types of information that's coming out. Again, you may notice here we have atmospheric correction band. So why do we need that? Well, of course, in this area, there are certain wavelengths where water absorbs the signal. And so you want to know that anything that is coming back to the sensor, is it due to the atmosphere, or is it due to what's going on the ground? That's an important part to remember about, especially about satellite-based Earth observation, because there is this huge thing called the atmosphere between the sensor and the target itself. So just to keep that in mind. But again, a lot of bands to play with, and a lot of information that can be extracted from Sentinel-3. Yes, I did mention. So the spatial resolution here, also to remember, is 300 meters, 500 meters, and 1 kilometer. Okay, so in order to be able to give a global daily acquisition, we need to open up, let's say, the viewing area, so we get a lot of reflection in. But that means we can't be as the resolution can't be as fine, because otherwise we would very much explode our data requirements, especially for acquiring the data. So next up is the Sentinel-2. This is another optical satellite. It's a fine spatial resolution satellite, which means that the spatial resolution is finer, which means we see better detail on the ground. But you also see that we have fewer bands, okay? And I picked out this particular figure, especially for those who have, let's say, some experience with other satellite-based observations, just to put it into context. So if we look, actually, this is Landsat, okay? So Landsat is at the 30 resolution, which is coarser than what we have for the Sentinels, and these are the Sentinels, okay? At 20 meters, but this is already going into the near infrared range. If we actually look at the Sentinels at the 10-meter range, we do see that we have this very similar bands to those that were available through Landsat, but narrower as well, okay? These were based both on requirements as well as technical. So again, a lot of the times when you have to design the satellite and the type of information that's coming down, it's you can't just do everything, and so that's why we do have these 4 bands at the 10-meter spatial resolution, which we'll see is actually pretty good. And then we have others that are coarser, so double that. Again, if you're thinking about different scales of observation, and again, even others that are at the 60 meter spatial resolution. But in total here, so if we count up the spectral bands, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 in total. Okay. Very similar to Landsat. That's not by chance. Of course, it's trying to continue in some way the history, because Landsat has been up probably almost 50 years now. So we do have a very large global data set again of Landsat data. And this is one way to be able to link them much easier. Okay. What else did I want to say here? And again, if we're looking at the amount of your chances of getting a good scene, we're looking at about a revisit of 10 days at the equator. But as we're getting up to higher latitudes, so again, in both in Europe and in Svalbard, we're getting much finer spatial temporal resolution, which means you can literally get a good scene every week at 10 meter spatial resolution, which before would never have happened. That's again another sort of plus for the Sentinels. There is more than one flying around, and that's why we see this capability. Because if it was only a single satellite, then you wouldn't be able to do this. Now, for the odd one of the bunch, I guess we can say Sentinel-1 is a C-band SAR, so we're looking at much longer wavelengths. But the cool thing about this is that it has its own energy. How would you say? It shoots its own signal, right? So essentially, what you're doing with SAR is you're shooting the energy, and whatever comes back, you're recording it. The advantage of that is the fact that you don't need the sunlight. So Sentinel-1 is actually acquiring both day and night, and it's acquiring both in both directions as well. So again, here we're taking just a quick overview of all the different types of products that maybe you're not familiar with from a SAR point of view, but SAR is certainly being used more and more within the vegetation community. First and foremost, because it's so much easier today to process it to something that is usable. And secondly, it's especially in areas where atmosphere has always been an issue. It's not an issue for the SAR satellite. Here, well, I won't go too much into detail, but there are different polarization modes. And for Sentinel, we can get VV or HH, which is vertical, vertical, and horizontal, horizontal. Basically, it means you're sending the signal in a vertical state and recording it, the return in a horizontal, or vice versa. Okay, lots of technical stuff behind that, but we're here just to look at the data and see what you potentially could do with it. And as I said again, because they have two flying, you start being able to monitor things much better. And again, if we're, there's Svalbard, and essentially we're getting down to a revisit day of 1 day, which is unheard of in the past. Again, I don't even know if you need to watch Svalbard every day, but that is something that I think you have an INSAR lecture coming up, and it's going to be based on this, and I think that's perfect for that type of information production. Again, just to tell you a bit more about what you expect to see. So as I said, it's an active sensor, so we don't have to have the sun out to measure anything. It is weather independent, but depending on the purist, of course, weather will influence. It is a signal. It is going through the atmosphere, and you will. For vegetation, I don't think it would be a big issue, but of course there can be some noise, I guess, that you can get out of it. And one of the things I did want to point out was about vegetation penetration. So if we look at it, the Sentinel-1 is a C-band, but there are other satellites that are the X-band, where you would get just the surface of the vegetation. The nice thing about C-band is you're starting to get signals from inside the vegetation. So you're starting to look a little bit at the vegetation structure as well. And that's something that I think is very important and starting to become valuable for the vegetation community. In the future, we should also have a L-band sensor coming, or S-band, I think it is. And here again, it provides even more detail about the vegetation. It should start building even a 3D idea about, the vegetation structure, for example, within forests or, other biospheres. Okay, so I don't have much time left, but this is the quick part. How do you get your hands on this data? I'm going to show you one way, which is through the Copernicus Open Data Access Hub, but there is a large number of other ways of doing it. I think in the links I provided you the DIASs, which stands for the Data and Information Access Service. These were specifically developed in order to simplify access to Sentinel imagery and data. Okay, not only simplify the access, but also the processing to bring the data to the state you wanted when you receive it. Okay, so that's I won't go into too many details because it's certainly worth a look. Some of these DIASs do have certain themes that they focus on more than others. Again, if you like programming, some provide better programmatic access, others are more visual, and you can play around and develop your own sort of processing chains before you extract the imagery. Another very interesting way of getting access to to Copernicus data, again, this is again certainly based on Earth observation information, is through the ESA thematic exploitation platforms. Again, it's just another way to encourage you to take advantage of what's already available from, let's say, the Copernicus and Sentinel ecosystem. There is a polar one. Unfortunately, I wasn't able to get my registration in on time. These are very specialized, I guess you can call it. So these are communities that have decided on based on the themes, what is the information or that can be extracted that's relevant to those communities. So I suggest to take a good look at those as well, and see what types of information you can, or data you can take advantage of. So processing Sentinel imagery, we're going to go through a snap in the next section. But just something I did want to mention, Send2Agri is again an open source software, which is based on Sentinel-2, and it has all kinds of processing possibilities. So again, if you're this type of person who hates programming and doesn't want to, you know, do all the pre-processing just to get to see the information you want, take a look at sort of the Send2Agri and see what they have available for you. I have to admit that from a vegetation perspective, agriculture, of course, is more lucrative than forests or grasslands, or you know, ecosystems and things like that. And that's why it might be necessary to sort of look outside of your domain, but they're still taking advantage of exactly the same types of information that you would for characterizing vegetation.